Good afternoon, everybody. My name is Carlos dos Santos. I'm a Senior Solution Architect at Red Hat South Africa, and welcome this afternoon to Red Hat Sub-Saharan African Forum Edition. My topic today, or my talk, my track is Transforming Virtualization for the Future, a refreshed look at virtualization. So just to give you a preamble, so we will cover a couple of slides, short period of time covering just a handful of slides, 4 or 5, and then I will roll over into a demo. So let's go ahead and get started. So what exactly is OpenShift virtualization? So OpenShift virtualization is really about bringing two worlds together, bringing the VM world together as well as our container platform world together. So you might be asking yourself, what is driving this? Why is there a need for this? So as we talk and listen to our customers, we hear our customers telling us that for them to be able to containerize their legacy applications is a very time-consuming and costly exercise. So they're happy to adopt new applications, new workloads, and in a container format onto an OpenShift platform, but they're quite selective about migrating legacy applications and only do so when they really have to. So more and more they're realizing that living in a world of virtual machines is going to be longer, more mid to longer term than what it is a shorter term thing, right? So essentially VMs are going to be around for a while still, right? The other thing is that ISVs are also packaging their solutions now as containers, but there's still a large number of ISVs that still deliver theirs as virtual machine images. So customers are now looking at this and saying, well, I'm going to be living in a VM world for a while, still time to come, as well as my container platforms are expanding and growing quite rapidly too. And we're going to sit with two management platforms. Where's the economies of scale and where are the costs going with all of this? So bringing the platform together is something that customers have been asking us about, and we certainly can do that with OpenShift virtualization. So what does a virtual machine in our container world really look like? Essentially, obviously, we run a virtual machine inside a pod. And within that pod, we run a thin KVM layer. And that KVM layer then sits underneath the virtual machine, and the virtual machine basically leverages those KVM services so that the virtual machine can boot up and operate as it would in a normal virtualization platform. Since it's packaged now as a pod, same way an application is packaged in a pod, there's a whole new paradigm around the virtual machine pod, right? And that paradigm is really Kubernetes and the way Kubernetes manages pods or containers. So virtual machine pods now all of a sudden benefit from the Kubernetes scheduler, Kubernetes deployment methods, as well as management methods. So VM pods become first-class citizens alongside the application pods as well. And there's no new fancy footwork, right? So to expose a network interface or a storage interface to a virtual machine pod is done in exactly the same way you would do it to an application pod. So to manage and to be able to communicate with our virtual machine pods, we have defined some new custom resources, and we've done that via custom resource definitions. So we have the capabilities to really manage our virtual machines the same way that we manage our application pods. So there's benefits to be had in the long term as well as in the short term, right? So for operations teams, ideally you want to end up with one platform where you can deploy your virtual machines or your containerized workloads as well as your serverless functions, right? Anything that your business requires, you have a single platform to do that. You can then gain economies of scale and merge infrastructure sets as well, reuse infrastructure as you migrate off the legacy application workloads. So roll over operational efficiency into collaboration and innovation. So by merging everything into one platform, we now have two teams coming together, the devs and the ops teams would work a lot closer together, and they're able to then collaborate and actually innovate much better together as they were today in silos. And then investment and modernizing your own skill set. So from an operations perspective, we live in a technology space, or we are in a technology era, you are in a technology field rather. And to to be able to transition to new technologies, we have to keep relearning and reteaching ourselves new skills. So by bringing your VM expertise to this new platform, deploying your virtual machines on a new platform at the same time, you're learning the new platform and learning a new skill set for the future, equipping yourself really well. For development teams, right, OpenShift provides a consistent developer tools and processes. So dev teams typically today have different tool sets for both to manage their application set on a virtual machine space, as well as then to manage the applications that run on a container platform. So they live in two worlds really, because the application doesn't live just on a single VM, or it doesn't live just in a container. By leveraging obviously the two components on the same platform, virtual machines and containers, along there side by side, the developers now can streamline or standardize on their tools that they're going to use and the processes as well. So modernize and integrate your legacy systems right now. Bring your virtual machine workloads today. OpenShift virtualization comes at no additional cost, so there's no delay, right? It is GA already, quick to deploy, and you'll see that in a short while in our demonstration. And then opens a whole new world for or options, let's say, for running Windows-based workloads as virtual machines on the platform. We can actually run older versions of Windows Server right on the platform. So a lot of benefits there for Windows-based applications as well. How do we develop and package this, right? So it's open source all the way. Upstream, the KubeVirt project, downstream, or the Enterprise Edition, OpenShift Virtualization, right? So we work closely with the communities to develop and build. Kubernetes native and friendly, right? So we haven't reinvented the wheel in this approach. We've just used Kubernetes native applications and custom resource definitions, right, to build the applications that were needed for the OpenShift virtualization stack. And all of this is deployed and managed, or the life cycle thereof is managed using operators. So relatively easy to deploy. We've become custom now with OpenShift version 4. To head over to the operator hub, select an application set or services you want to install, and they get installed as operators and pretty much deploy themselves and manage themselves as well. So with that, we can now move over to a demonstration where I'll basically show you how to install OpenShift virtualization and then deploy a couple of VMs and have a look and see how we manage and control those. Okay, so we start off our demo by logging on to our OpenShift container platform, navigating over to Operator Hub, and then searching for virtualization. We select the OpenShift virtualization operator and install. Latest version is fine. Make sure the right namespace has been selected. We go ahead and install. Installation of the operator itself takes just a couple of minutes. If we go across to the left hand side and we drop down on workloads, at this point we don't have any virtualization menu. That menu will be populated as soon as we have our OpenShift virtualization application services and APIs successfully and fully installed. Alright, so we've reached a succeeded status, so we can go ahead and now create our OpenShift virtualization cluster services. So I can create a new hyperconverged cluster. The defaults work relatively well, so I'm not going to make any drastic changes here. And then we also want to deploy our host path provision of services or APIs. And this enables us to attach to devices that are local to our worker nodes where our virtual machines will be hosted and deployed. Go ahead and install, and again the defaults suffice. Head over back to installed operators and we can see installation is pending, and this does take a couple of minutes. While the installation is busy running in the background, let's go and have a look at what our demo environment looks like for today. We're going to have a look at nodes. We get to see that I've got 3 master nodes and 3 worker nodes, so pretty much a minimum cluster setup. All of these nodes, however, are virtual machines running on one single physical server. That then naturally does mean too that when we deploy our virtual machine workloads on OpenShift virtualization, that there will be VMs running within VMs. So that basically adds up to nested virtualization, which for demonstration purposes might be fine, but we cannot do that in production. So for production, the worker nodes where you run your virtual machines have to be bare metal servers. If we go and look at the overview, just what I wanted to point out here is, so virtual machines will need a persistent storage backend. For the demonstration, I've deployed or installed OpenShift container cluster as well, OpenShift container storage. And if we go look at, we've got 3 nodes, and those are actually the same 3 worker nodes we will be deploying our virtual machines to. Okay, so we just need to wait a couple of minutes to get our OpenShift virtualization application services and APIs fully installed. Okay, so our installation is now succeeded and we're ready to move on. If we go over to workloads, we now have the virtualization menu that I was mentioning a couple of seconds ago. We click on virtualization. Let me first and foremost go and select the right project. We've got a virtual machine menu as well as a virtual machine templates. Virtual machine templates pretty much similar and identical to the way we understand virtual machine templates in a virtualization environment today, like VMware or Red Hat Enterprise Virtualization. We head over to virtual machines, go down the drop down here, we see new wizard, so we can create a virtual machine instance through a guided wizard, and we will do that in a short while. We can create from a YAML file, which I'll also demonstrate, but before moving on there, let's have a look at import with wizard. So import with wizard gives us a number of choices. I have dropped the drop down here, but the video recording doesn't actually capture the drop down list, so I'm going to select. There's 2 of them. One is Red Hat Virtualization, and the other one is VMware vSphere. So we can attach to any one of these providers, discover the virtual machines that are running on those hosts, and then import them into our OpenShift virtualization cluster. So my first demonstration will be deploying via YAML file. And we see if we select here deploy via YAML, we get a sample template presented to us. I'm going to just clear that up, come across here and copy the template that I want to deploy, which is a Windows virtual machine. Pretty much normal YAML. Some of the things we can point out is we can obviously adjust our CPU cores, our memory allocation, the live migration strategy. You can set a host name. And then in this instance, I'm leveraging the Multis network capabilities to expose this virtual machine to an external network and not actually the OpenShift SDN network. So this is done by means of that host provisioner that we installed earlier on. Each of our worker nodes has got a secondary NIC called ETH1, for example, and on ETH1 we've created a bridge, and this is a definition. It will attach this interface, this NIC0, to this bridge 1 on the worker node where this virtual machine gets configured or scheduled. And then we've also defined the volume that we're going to use to boot, and our persistent claim is a volume also called Win2019 host path. I'm going to go ahead and create the virtual machine, and you'll see it almost immediately starts up because we're using a pre-populated volume already. So the boot process should start in a short moment. So we have a quick overview here. We have details for our virtual machine. We can see which workload got scheduled on, an inventory telling us number of NICs, disks, and if we've got a CD-ROM attached, in this case we do. It will soon start collecting utilization statistics as well. There we go, almost in real time. Head over to console. We should see that our virtual machine has now started the boot process. Virtual machine instance is now fully booted, and we're on our console here on our OpenShift container platform web user interface. We're going to interact with the virtual machine, basically just do a login. Alright. Okay, hopefully I've typed the password correct. Looks like I have, so we will just get a login screen. In the meantime, let's head on over to our overview. Again, you can see that we now have an IP address being assigned, which is .63, and our metrics are populating nicely. So this virtual machine does have an RDP port exposed, so I've actually connected to it already in the background using the .63 IP address. So this is an external network, remember, this is not now our OpenShift SDN network. Hence I can reach it from outside without having to do any expose any services or any routes, etc. So I'm going to connect here and then rendezvous, and we'll come back here in a short while. Alright, back to virtual machine. So we've seen an example where you deploy using a YAML file, and we can do another example now, deploy with new wizard. So for this instance, or for this example, I'm going to install or deploy a Fedora instance, and I'm going to call that Fedora 31 forum for the forum day, right? Again, the drop downs don't show on the video, so I'm going to quickly run through them. We have a couple on the list: Pixie boot, URL, container, or a disk image. And for this example today, we're using a URL. So I'm just going to head across here, pick up my remote location where my image is, an operating system. The list here is slightly longer, so I won't read through it, but essentially the list of supported VMs on OpenShift Virtualization is the same as those that we support on our Red Hat virtualization platform. Flavors, we have tiny, small, medium and large as a default, available for your use, or we can go for a custom size, or custom flavor rather, as I am. And then workload profiles, we've got desktop, high performance, and then server. This particular virtual machine, I do want it to attach to the pod networking. So pod networking is essentially the internal OpenShift SDN network, pretty much the same network that a container would attach itself to. But I'm also going to add a secondary interface and bind to that external network as well. So tuning bridge, remember we saw it in the YAML file, and here we're just selecting it from the guided wizard. So this machine will have two network cards and live on two different networks. For our storage disk, we're going to make some changes here. So we can leave the name root disk. The size 10 gigs is fair enough for me. But the storage class, so remember we had OpenShift container storage deployed, so we can use the persistent storage in the backend. And I'm going for Ceph RBD, so that is a block type volume. And I'm going for a shared access mode of read write many. So the reason for doing that is twofold really. Ceph supports read write many block devices, and OpenShift Virtualization knows how to utilize it to leverage it for live migration purposes. And we can give it a hostname again. Populate an SSH key, custom script, we can quickly pop in here. This is basically a cloud config. If you're used to deploying cloud instances, you will be familiar with cloud, with cloud init. You could utilize an existing cloud init script and populate it here on the user interface as well. If you need to attach a CD-ROM, the capability and functionality is also there. And then lastly, you get a summary screen to show you all your selections. And you have a chance to go back and fix them if you need to. And lastly, I need to just start the virtual machine. That's an optional. Okay, so let's go back to virtual machines and have a quick glance at what's going on here. So now I've got two. We've got our Windows server, which is up and running now for a couple of minutes, and we have our Fedora 31 forum instance that's gone into a pending state, and let's kind of understand why that is the case. It's gone into pending for this reason, right? So we had a image that we were sourcing from a remote location, and we created a RVD block device on our persistent storage cluster in the backend. This importer pod is automatically started to take that image and populated the volume with that image. So it's doing that in the background. And once that's completed successfully, the virtual server will then, or the virtual machine will then deploy and install, or not install, but actually boot. Okay, so this is running through, and we'll give this a little while to complete. Right, the import of our image was successful, and we can see that our virtual machine has now transitioned into a running state. We can go and have a look at it and see that our metrics are also now just starting to populate. Let's go and have a look and see what our console looks like. So for Linux hosts, there's two types of consoles. We can see the server is already in its boot process, VNC console, which you can see there at the moment, and then also a serial console, which I tend to prefer. Okay, so back overview. We can see two NICs, two disks, pretty much what we expect to see, and our utilization stats. At this stage, I do want to just rendezvous back to our RDP connection, which we kicked off just now. We can see we're successfully connected to our Windows server. It is obviously a demo instance, and its license is due to expire relatively soon. Perfect. Okay, so like any normal pod or container that you deploy, there's always some services embedded that you obviously want to expose, right? We don't just want to deploy things and not be able to actually connect to them or use them. So typical actions you may perform with your container pod or your pod is to expose a node port service or expose a web service. And we can do that on the user interface. I'm going to switch over to the command line interface and actually then go and expose some services using a utility that is part and parcel of the OpenShift virtualization deployment. Okay, so you should be seeing my command line terminal at the moment. You can see our two instances, our two virtual machines running. That's through OCGet VMI. So this is one of the new resources that's made available. Okay. OCGet service. And we can see that we have some services exposed, but not the ones that we're looking for. So I'm going to go ahead and just grab our utilities here, or copy and paste that is. So I'm going to use a virtctl utility to expose a virtual machine instance Fedora 31 forum. The service name is going to be forum SSH and the type node port. So I want to expose SSH at a node port level so that I can connect to my virtual machine instance remotely. So we've exposed that service out, and let's go and expose port 80 as well. So on this particular Fedora instance that we've deployed, I have an Nginx web server running, so we want to connect to that remotely as well. I'm just going to expose that service as well, port 80, call that service Fedora forum service. And to access our Nginx web service, I'm going to create a root. And I've intentionally used the command line utilities to do these. You could use a web user interface as well, but I've used command line just to demonstrate that we can interact with our virtual machines in the same way you interact with your pods for containers, right? Or your application pods. So I also get nodes. So we know that our virtual machine is running on worker 3. Let's confirm that. Okay, Fedora Forum 31 is running on worker 3. So let's try an SSH on our node port that we exposed. Using our port. Okay, so I haven't yet listed the ports that were exposed. So let's just quickly go and expose those properly. We'll go and have a look at what that looks like. As you get service. But there we go. That's what I was looking for. Our node port 22 is exposed on port 30145. So SSH root at our worker node on port 30145. Oops, a little bit of lag. We have a connection, right? Just going to confirm that our Nginx service is up and running as well. And indeed it is. Okay, let me disconnect off here and go OC get root. It's the root that was exposed for our Nginx service. I'm going to switch on over back to our terminal, switch away from our terminal and go and actually switch back to our web user interface and hopefully successfully connect to our service that we exposed via root. And there we go. So far so good. The demo codes have been good thus far. We go back again to our virtual machines. Let's see what else we can do with a virtual machine. Before we do that, okay, so now that the virtual machine has been up and running and the guest services have actually started and been able to report some information, additional information about the virtual machine, we can see that our Fedora instance is running on an external IP as well, or public IP of 123.64. So let's switch over to our command line and just start a continuous ping. Oops, ping 192.168.123.64 was it? Let me quickly have a peek. 64 indeed it was. Okay, so we've got a continuous ping running. I'm guessing you already know why I've started a continuous ping. So let's switch back to our web user interface. And at this point, let's go back to virtual machines. I just want to note, make sure I've got the right machine. There we go. We're running on a worker 3. I'm going to initiate a live migration of this virtual machine and move it off to another host. So the migration job will kick off, and naturally you'd expect it's being run by another pod service in the background. Okay, pod initializing, and it's actually performing the migration as we speak. Back over to virtualization. In a short while, all going well, we should see that the workload has moved over, and we just did see that now. It's now crossed over to worker 2. Let's switch over back to our terminal window and take a look if our ping is still happily running, and as expected it is, right? So virtual migration is pretty much enabled from out of the box, nothing special to be done, and it's quite important where virtual machines are concerned, right? The way that pods or application pods typically work is to terminate and then restart somewhere else, whereas with virtual machines the default is to actually do a live migration instead of terminating, because at virtual machine you don't want to terminate and restart. Okay, if I switch back then to our Windows or our web user interface, we can go and have a look and see our hello world is still accessible, and pretty much it is. I could have run an auto refresh. Alrighty then, so that does bring me to the end of our demonstration for today. One functionality I didn't managed or didn't do the demonstration of is to clone a virtual machine. It's pretty straightforward. It's 1-2 clicks, and then you get a clone of your virtual machine. It does power off the original instance and then perform the clone and then start up the new instance again. Alright, so let's go back to our presentation screen and just wrap up for today. So some of the takeaways you can have, I'm sure the slide deck will be shared or and be downloadable from the portal where we're on at the moment. Customer story, Goldman Sachs revamps and basically capitalizes on OpenShift virtualization. It's a good story to go and read, as well as some links to the documentation. There's a lot of blogs, demos, and videos available on OpenShift virtualization, so there's some links there to get you started, and then the upstream, kubevert.io. So thank you for joining us today. I hope it was insightful, and that, yeah, virtualization for the future is set to look a bit different from the way virtualization does or traditionally looks like today. Thank you very much.